Before you start gathering components or opening up a computer program, you need an idea. What do you want your circuit to do? Maybe you want to build a simple LED light or a small alarm. Having a clear goal will guide your design process. Once you know what you want to create, think about the electrical parameters. This means things like the voltage and current your circuit will use. These are important for choosing the right components later. Start simple. Don't try to design a complex computer on your first attempt. A basic circuit with a few components is a great starting point. As you gain experience, you can move on to more challenging projects. With your idea in mind, it's time to draw a schematic diagram. Think of this as the blueprint for your circuit. It uses symbols to represent different electronic components like resistors, capacitors, and transistors. Lines on the schematic show how these components connect. This diagram helps you visualize the flow of electricity in your circuit. There are free computer programs that can help you create schematic diagrams. These programs often have libraries of component symbols, making the process easier. Take your time and make sure your schematic is clear and accurate before moving on. Now it's time to choose the physical components that will make up your circuit. This is where your schematic comes in handy. Each symbol on your diagram represents a specific electronic component. Refer to your schematic and make a list of all the parts you need. This list is called a bill of materials. When selecting components, pay attention to their specifications. These include things like their resistance, capacitance, and voltage rating. Ensure the components you choose match the requirements of your circuit. With your components selected, you can start thinking about how they will be arranged on your circuit board. This is where you'll use PCB layout software. This software allows you to place your components virtually and connect them with traces. Think about the physical size of your components and how they will fit together on the board. Keep in mind that components can generate heat. Make sure to leave enough space between components for airflow to prevent overheating. This is especially important for components that generate more heat, like power regulators. Section 5. Connecting the dots, routing traces. Once your components are placed, it's time to connect them. This is done by routing traces on your PCB layout. Traces are thin copper lines that act like wires, carrying electrical signals between components. Use your schematic as a guide to ensure that you are connecting the components correctly. The width and spacing of your traces are important for ensuring that your circuit functions correctly. Thicker traces can carry more current, and proper spacing prevents short circuits. Section 6. Checking your work design rule check. Before sending your design off to be manufactured, it's crucial to check your work thoroughly. Most PCB layout software includes a design rule check or DRC feature. The DRC automatically scans your design for potential errors. This includes things like traces that are too close together, components that are too close to the edge of the board, and incorrect trace widths. Carefully review any errors or warnings flagged by the DRC and make the necessary corrections to your design. This step helps ensure that your circuit board will function as intended. Section 7. From Design to Reality, PCB Manufacturing. With your design finalized and checked, it's time to have your circuit board manufactured. Many companies specialize in PCB manufacturing. You'll need to provide them with Gerber files, which are the industry standard format for PCB designs. Most manufacturers have online calculators that allow you to get an instant quote for your PCB based on its size, number of layers, and quantity. Choose a manufacturer that fits your budget and turnaround time requirements. Once you've selected a manufacturer, upload your Gerber files and place your order. Section 8. Bringing it to life, assembling your circuit. Once you receive your manufactured PCBs, it's time to assemble your circuit. This involves soldering the components to the board. Soldering is the process of melting a metal alloy to create a permanent electrical connection. You'll need a soldering iron, solder, and a few other tools. There are many online resources and videos available to teach you the basics of soldering. Take your time and be careful when soldering, as excessive heat can damage components. Use a fume extractor or work in a well-ventilated area, as solder fumes can be harmful if inhaled. Section 9. Testing time. Does it work? With your circuit assembled, it's time for the moment of truth testing. Connect your circuit to a power source if required, and verify that it functions as intended. Use a multimeter to check for continuity and voltage at different points in the circuit. If your circuit doesn't work correctly, don't despair. Debugging is a normal part of the electronics design process. Carefully check your connections, component orientations, and refer back to your schematic to identify any errors. With a little patience and persistence, you'll be able to troubleshoot and get your circuit working as expected.